In the previous video, we described determining exchangeable sodium percentage, which is simply the amount of exchangeable sodium on the exchange sites as compared to all of the exchange sites, or the cation exchange capacity. So let's do a little bit of math to derive the exchangeable sodium percentage. So here's an example. The soil has a cation exchange capacity of 30 milliequivalents per 100 grams, and the exchangeable or extractable sodium is 1,242 parts per million. That unit is the same as milligrams per kilogram. And so what is the exchangeable sodium percentage? So you've got to remember how we did these sort of calculations for CEC back in the cation exchange capacity unit. And we convert parts per million, or milligrams per kilogram, using the atomic weight of the element, and in this case, sodium. And if you went to the periodic table, it has an atomic weight of 23 or 23 grams per mole. So let me share with you the math on how you determine ESP. And we're going to keep this simple because you see or note that the CEC is already in the units that we need for determination of exchangeable sodium percentage, but sodium is not. So at the very top of this slide is what you just saw on the previous slide. We know that the CEC is 30 milliequivalents per 100 grams. Right, CEC is 30 milliequivalents per 100 grams. The exchangeable sodium is 1,242 milligrams per kilogram. That's the same unit as parts per million. What we need to do is convert exchangeable sodium concentration to milliequivalents, and it should say per 100 grams. So if you recall, this is the puzzle that I'm teaching you, right? If you recall from Unit 4, the cation exchange capacity unit, there was a rule of thumb that you were given to make this conversion from milligrams per kilogram to milliequivalents per 100 grams. And here is the conversion shown right here on this slide. You take the milligrams per kilogram times the valence of the ion you're working with. In this case, it's sodium. It has a +1 charge. And you divide that by its atomic weight. And you perform everything that's inside parentheses first. And then you take that value and divide by 10 to give you milliequivalents per 100 grams. And so therefore, we take 1,242 milligrams per kilogram times the valence of sodium, which is 1, divided by 23, which is the atomic weight. I don't know what that number is. I'm guessing it's 54. And you divide that by 10, and that equals 5.4 milliequivalents of sodium per 100 grams. And then you plug this into the equation that you saw in the previous video. The exchangeable sodium percentage equals the exchangeable sodium in milliequivalents per 100 grams, divided by the CEC in milliequivalents per 100 grams, and then to convert it to a percentage basis, you multiply by 100. So it's simply 5.4 divided by 30 times 100, or 18. And this tells you that 18% of the exchange sites in this particular soil is occupied by sodium. And that may mean nothing to you, but it means something to me. And I'll tell you what that means. And I'm not sure if we'll learn about this in this unit or not, but oftentimes when we have exchangeable sodium percentages above about 5, then the soil might be affected by sodium. And this soil is certainly affected by sodium, and we would need to take measures to reduce the sodium ions that are adhered to the CEC sites and remove them and rinse them out of the soil if possible. And that's sort of a little prelude to what you'll learn in one of the subsequent videos.